Okay, welcome everyone to the third section of the Mars Day. Here, basically, Milana already covered the basics in the first presentation, and Alice showed the nice new tools we have to extract the data and also to visualize the data. And now I will focus a bit more on how the system actually works and how to use it efficiently. Basically, you already learned that Mars has a queuing system, so each Mars server has its own queuing system, and there is also a queuing system on the web API, which sits in front of the Mars. However, if you submit request using Mars client on the HPC, or also using EarthKit from the HPC, it will directly go to the queue on the Mars servers. And then on the servers, we have different priorities to make sure that everyone has the same experience, all the users, and also to make our operational work to protect it from activities of private users. So when we are, each request has its own priority, and when we calculate priority, what we take into account is the user type, age of your request or time spent in the queue, and total request queue. Total request cost take into account the number of tapes and the total number of fields you wish to retrieve. And then we have two group of limits. So each Mars server will have a global limit, which means that only a fixed number of requests can be active at the same time. Only fixed number of requests, which is lower than total number of active requests accessing tape data which is not available online. And also we have a smaller number of active requests for each tape number. So for example, we can host 50 requests accessing more than 2 tapes, and then 30 requests accessing more than 3 tapes. Then we have per user limits. So as a user on, for example, operational Mars server, you can have at most 20 requests, 20 active requests. And then there is additional limit of number of requests per user for offline data. So for example, you can have up to 10 or less requesting data which resides on tapes. And then if you increase number of tapes in your request, then we have even further limits. So as a user, you can run only 3 requests, for example, which are accessing more than 3 tapes. And we also have, in addition, limit for number of requests you can submit to the web API, though the limit on the web API is in most cases more strict than limit per Mars server. So all of this is taken into account when Mars is scheduling your request. What you should, so to use these limits in a most efficient way, you should be careful, and you should request all the data you need which resides on one tape in one go. So you have seen in the previous examples, Milana showed the last page of Mars catalog, which is basically showing you at the end of your selection all the fields which are available on the same tape, with one exception. She also showed that. So for example, for analysis, I here also included for each of these bullets, there is a link to Mars catalog, which you can click and go there if you have access to Mars catalog. So for example, we store 1 month of analysis on one tape. So when you are want to download a large time sample of analysis, then you always go 1 month of analysis per request. You will never do one day of analysis per request, because that would consequently access the same tape 30 times, assuming that month has 30 days. Then for forecast is a bit different, because in forecast we have more data, we have all the steps. And then usually it's just one forecast. So whether it's 0 UTC or 12 UTC or 6 UTC, one forecast is available on one tape. And also for specified level and for specify level types. And then when you select your day of forecast, when you select level type, which is surface, model level, pressure level, then you do all parameters and all the steps and all the levels in one go. Ensemble is very similar to forecast. Basically, in Ensemble, you will have, in addition to all these keywords, you will have a number which indicates number of ensemble. And in Operational Forecast, we have 50 of them. So all 50 ensemble forecast for a selected day, a selected time, and selected level type reside on the same tape. So what you don't want to do, you don't want to download individually one ensemble member in one request and then the second ensemble member in second request, because that would run 50 requests accessing 50 times the same tape. And as Milana showed, and I will talk about this a bit later, there is exception which needed to be made with cycle 48R1 when we increased ensemble resolution to 9 km, and basically we start producing significantly larger data from this product, and we couldn't fit it to one tape file. Another example, and one of the most popular data set, is ERA5, which is the latest available global reanalysis. So in ERA5, we have also forecast and analysis, and because forecasts are quite short, they go 12 hours ahead. Both forecast and analysis for selected date and time, there is 1 month of such data resides on one tape. So if you are downloading ERA5 for selected level type, you want to download 1 month of analysis or forecast in one go. That is the most efficient way. And I also added examples for AIFS because that is new. Last time we did this course 2 years ago, we didn't have operational artificial intelligence model. So in general, AIFS is producing much less data than the NWP IFS. So we can store 1 month of forecast also from IFS in one tape. So be careful if you switch from the classical NWP model to downloading AIFS forecast. Instead of downloading one forecast per request, you need to go to 1 month of forecast per request. And we also have AIFS ensemble. So AIFS ensemble is quite similar to NWP ensemble. So one forecast for selected day and time and level type resides on one tape. So yeah, we will make this presentation available, and then you can check the last page of Mars catalog for each of these data sets, which will tell you what resides in the same tape. So what you should do before starting any activity is always to start with the Mars catalog. Mars catalog has a nice feature to design request for you. And in most cases, you will not download this data from the web interface. You will just copy that request and paste it to a batch job on the HPC from where you will download the data. But it's quite convenient because you don't know parameters ID of every parameter, and you don't know Mars language well. So the Mars catalog will do all of this for you, and then you just need to copy and paste. In Mars catalog, you have this option of checking availability. So most people who are downloading operational forecast, they will not bother to check availability before they download because it's consistent. Every day we produce the same thing. And then we have once a year a new cycle, and then things changes. But you can run it safely 1 month of 1 year of dates to download them without checking availability, because it's quite reliable. On the other side, if you are downloading things like observations, research experiment, which are not that consistent, then you need to check availability every time. Because, for example, I can run research experiments IFS, and then I can decide to archive one set of field for one run. Then on the next run, I can archive something else, and then I can skip the next date and start to jump to the future, a few days to the future. So it's really recommended to check the data availability every time for such data sets. And then you will also, Mars catalog will give you the number of fields. Usually for typical Mars requests, they can go to hundreds of thousands of fields, and that is okay. And typical Mars request might have few tens of terabytes of data. That is also quite okay. Current tapes supporting Mars are 20 terabyte tape, and then one tape file is approximately up to 4.5 terabyte, something like that. So there is a lot of data on these tapes. And usually people download just one small set. They select some parameters, and they select sometimes limited areas. So in the end, it can be much smaller. But if you see tens of terabytes, don't panic. It's still fine for Mars. Then you should check the computing resources on the client side where you run this request. And typically for large retrieval, the best performance you will get by using Mars client on ECS or HPC is the same thing. So you want to check basically in Mars request, you have this target file where the data will be stored. And ideally, you want to redirect this to Scratch and HPC Perm, which are large file systems. And you might want to check if you have with quota command, which you learned previously on the HPC presentation, to check that you have sufficient space on your disk to store this data. If you are downloading data which is offline and might include more than one tape as well, you need to take into account that it might take a long time. It might be finished in less than 1 hour, but it might take more than a day. And then you need to make sure that your batch job, which you submit to retrieve the data, has sufficient wall time. So on the HPC, maximum wall time for fractional jobs is 2 days. So you can use 2 days if you specify this. And on ECS, we have this long job category, which can go to 7 days, which is even longer. And then what you also need to consider is when you specify post-processing options in the request, and that is keywords, grid, area. Because resolutions are getting higher and higher, and then if you want to retrieve a global field with and multiple fields on global grid, and then you want to do interpolation, for example, from reduced Gaussian to lat long, and we are talking about kilometer scales, you would need a few gigabytes or a few tens of gigabytes of memory to do this interpolation without having a memory issue. So you need to make sure to set to increase default memory if that is needed. For example, we have seen this in the destination Earth data, which are global forecast on 4-kilometer resolution, and for that 2 gigabytes are not sufficient even if you retrieve just a few fields. We mentioned already you need to retrieve as much as possible from one tape file once you have your request active. And what you should avoid is to constantly access the same tape. If you do so, you will see in Mars output of each of your requests, even if they are successful, if they complete without any errors, there is a lot of useful information in there. And one of the information is your efficiency, which is written in percents. Maximum efficiency is 100%. That means that during 24 hours, you will not access the same tape twice, and that is ideal. But if you see numbers go lower than 50%, then you can think about your efficiency. You can check the Mars catalog. In the end, if you cannot see the reason why your efficiency is that low, you can always contact us, and then we will help you to improve it. In the end, the system benefits, other user benefits, and of course, you will have the most benefits if you do efficient requests. Another tip we all quite often give to the users, yesterday we had ECFS short session about ECFS, which is if you want your personal archive, which is based on similar technology like Mars. And then sometimes people want to store data from IFS or something else which is available in Mars for themselves in ECFS. And there is no much point in doing so. So for example, even if you need like a small area of what is available, a regional area of what is available in Mars, and then you extract that from Mars, you store it in ECFS, it still goes to the tape. And then the slowest part is to get the data from the tape. So you will not see much of the benefits in downloading your post-processed data from ECFS in comparison if you retrieve it again from Mars. So I here included a snapshot from Mars catalog, and then wanted to highlight this option. I don't know if you see it well enough. For me, it's a bit blurred. But the third option from above, when you're on the last page of Mars catalog, is estimate the download size, and that is quite useful. Then you see number of tape files, number of fields, and you see the total size. However, this is also quite limited because when you are on the last page of the Mars catalog, that is already in 99.9% of cases one tape. Yeah. And people are mostly concerned about number of tapes. But for example, an average user, they are interested to know how, if I select, for example, 7 forecasts or 30 forecasts, how many tapes is that? And unfortunately, you cannot do this in the Mars catalog because this is only available on the last page when you select your dates and everything. So to do this, you need to run a Mars list action, which is similar to request. Just instead of retrieve, you run list command, and then you can select a range of dates or range of everything, and then you can see on how many tapes that data is placed. One typical example can be that quite popular data, for example, surface fields from the deterministic forecast, operational deterministic forecast, because they are extracted so often, they are quite often available in cache and in disk. And even though one of these forecasts is on a separate tape file, you might find if you run your list command for 1 month that this is on 2 or 3 tapes. And then it might be better to download 1 month rather than downloading 1 day per request. So list is a Mars action. Other actions are archive, retrieve, but you will mostly use retrieve and list. So when you run your Mars request with a list, you get amount of data, number of fields. Basically, everything you see in Mars catalog is just that you have more options of playing with keywords and changing values. It has a nice feature. If you add output equal cost, then you will get a number of tapes and number of tape files alongside the output. And this is something you can run interactively because for Mars request, you will want to submit this as a batch job to keep because it requires a lot of resources. If interpolation is included, it can take a lot of time. And then if you run it interactively, you might run out of memory or your SSH session can be terminated. But list is quite quick. It contacts only the database. It doesn't actually retrieve the data. So you can run such things, such scripts interactively on a login node. It's not a problem. And then list has some defaults. So basically, if you don't specify a Mars keyword like step, level, then it will assume all steps and all levels. And so you don't need to bother with specifying all of them. It's fine if you don't specify. However, things like class, experiment version, stream, type, and date, you need to specify that. You cannot run it without date, assuming that all the dates, because we saw in the chat someone asked, we have forecast since 1985. So you cannot, it would be a huge query. You cannot run all dates. So what is specific to list is that only checks the Mars archive, not the field database. And field database, what was mentioned in the earlier presentation, field database is FDB. How we call it is basically a data stored on the HPC file system, which is similar to your HPC and Scratch, and therefore it's quite high performant. But Anyway, if you are run list command to check the cost of your request, you are not interested what is in FDB, because if something is in the FDB, you will get that quickly. You are interested how much, how many tapes and how much of the data is on tape. And then, like with the Mars request, you can specify a target, but in this case, in target, you will see the output of the list. So you will have these numbers in your target file. And this is one example of a list request. So the only difference between list and Mars is it is first action, list or retrieve. And then when you run it, you get something like this. And here you have the total volume of the data you requested. You have also more details about the each parameter from your request. But if you enable this output equal cost, then you will have additional things in your output, and that will include number of tapes and number of tape files. And number of tapes in bold here, because that is the most important thing. Okay, so another thing you can do in Mars catalog is to check the availability. That's the first option. Already mentioned that. So I will not spend any more time on this unless there are questions. But basically, it will print from your given request, it will print a list of fields which are available. So quite useful for data sets which are not consistent. So you specify everything you are interested in, and then you get a sub request of what is available, and then you can retrieve only that. Things you should avoid. So we mentioned that all is supported for some of the keywords, like level list. You can specify all instead of specifying 1 to 137. And some people would use this because sometimes in the IFS, we will change the vertical resolution. And then people think, okay, if I specify all, I will get all vertical levels. And I don't need to bother with changing my request when I go from one cycle to another where the vertical resolution changed. Yes, but this has significant consequences on the efficiency. So how Mars works, at the end of the request, Mars will calculate number of fields that you got, and it will compare that to the number of fields you requested. And if that number is matches, Mars will stop there and it will complete without errors. But if that number is different, and for example, you retrieve less fields or more fields, then the Mars will throw an error. And basically, when you use all, Mars cannot calculate number of fields because Mars doesn't know how many levels there are for your request. It will give you all the levels, but it doesn't know how many of them are going to be there. So it's always better to specify explicitly, and you don't need to do 1, 2, 3. You can just write 1 to 137 by 1. For steps, you can write 0 to 24 by 3. So that is always much more resilient. And also we introduced expect equals, so you can specify number of fields you expect to retrieve. And then one option is any. Quite convenient, people think, because well, this was introduced because it was needed for things like observations and which are not consistent. You really cannot, you need to use it. But 99% of the data sets, they don't need this. And then people think, okay, it's quite convenient. I don't want my Mars jobs to fail. I will just retrieve whatever it is available, any subset which is available. And then this again has terrible consequences on the efficiency. Because, for example, if you say expect any, okay, and then Mars finds all the data you need, you want to retrieve in FDB, you get it in a minute. But then Mars says, okay, but I don't know if this is everything because I cannot calculate number of fields. And then what Mars will do, Mars will check the tape system to retrieve the same data, which was already on the disk on the HPC in FDB, to see if there is anything more there. So instead of 1 minute, you can spend 1 hour requesting data. And this is something as a user I would always avoid if possible. So yeah, earlier we mentioned change of ensemble resolution in cycle 49R1, which is our current operational cycle. And this is one example where producing additional data because we had bigger HPC in Bologna, and then the infrastructure, DHS infrastructure supporting Mars could not follow that in the development. So basically, surface data, because we have so many parameters, the total volume is around more than 12 terabytes. But in Mars, one tape is still 20 terabyte, but one tape file cannot be bigger than half of the tape. So we had to split this. Instead of one, we had 3 tape files. So you can see here in two options in Mars catalog. On the left-hand side, in cycle 48R1, and then on the right-hand side, 49R1. So you can see if you specify just one parameter on all steps on model levels, the total size is more than 4 times bigger because of double horizontal resolution increase. And therefore, you will also see that what used to be on one tape file and one tape is now 3 tape files and 2 tapes. And people usually expect when they specify one forecast that this will be one tape. And when they submit requests like this, the issue is that you have extra penalty because you are asking for 2 tapes and you spend more time in queue. And then after spending more time in queue, you need to retrieve more data. So that's another issue. So people often ask, okay, but if I still specify the same resolution as before, 0.2, for example, and my target file is still the same, why is my Mars request with 49R1 taking so much longer than what 48R1 was? And the answer is because there is 4 times more data to be retrieved and 2 times more tapes to be mounted to the driver before you can apply post-processing and create what you requested. And yeah, by the way, 49R1 was implemented on 12th of November 2024. So if you retrieve data after this date, and surface data from ensemble, you need to be aware that this might take more than one tape. What is useful to know is that we know how we split this data across different tape files. So we split them by step. If we go back to Mars catalog. Yeah, so here on the left-hand side, so we will put first 54 steps to one tape file, and then all ensemble members, all levels, and all forecasts. So the column to the left is if you want, the upper loop, and then the second third of the steps go to the second tape file, and then the last tape file is populated with the third group of steps. So if you don't need all the steps, you are still good. If you need forecast just for the first 2 days, it will be one tape file for sure, even if you take all parameters or levels or sample members. Yeah, but I didn't mention solution. So we are working on solution to solve this. So we already have a bigger tape, 50 terabyte tapes, which are installed in tape libraries supporting ECFS. Later this year, or maybe beginning of the next year, we will have these tapes implemented on Mars as well. And with these bigger tapes, we'll be able to archive all of this in a single tape file. So it will be quite some improvement. And we want to have this before we have 50R1, the next cycle, which will be implemented in Q1 next year. And when mentioning 50R1, 50R1 will also bring some changes to Mars. Basically, in the current cycle, the ensemble control member is bit identical to deterministic forecast. So we are running two forecasts which are without any differences, and therefore in the next cycle in 50R1 we will deprecate what is called stream info and then control forecast. So in the stream info you will only find ensemble members, and then stream upper type FC will be the same as it is now. But if you need control forecast, you need to fetch the deterministic actually, not the control. Also, another thing is that we are now keeping data produced at 6 and 18 UTC cycles under the different stream, which is called SCDA for atmospheric forecast. And then we keep the main cycle 0 and 12 under stream upper. So we will merge those two. Everything will be under stream upper. So in the end, things will be much simpler from Mars side, from the users than they are now. But there will be this change. So anyone who is retrieving from Mars, for example, a stream info type CF control member will need to change their request to ask for upper deterministic forecast instead. And they can do this already now because these two are identical. Okay, I think I'm close to the end. So if you need any help, if you are not having errors with Mars, but you are planning to retrieve a large volume of data, or you are unsure how to do things, you are always very welcome to contact our support. And then before you even try, of course, if you have any errors with Mars, any issues, things that are not working, you cannot download the data as well, you can contact us. When you contact us regarding any errors, always paste the full Mars output because it's so verbose. It gives us so many information which are quite useful for us to investigate and also for you as a user. If you don't do this, then we need to go back to you, and then we ask you to provide this. So some time is lost in the communication. You also need to remember that we monitor all these services and we monitor user activity, individual user activity. So if we see that someone is using continuously Mars in a very inefficient way, we might contact you, but don't be afraid. We contact to help. And yeah, we might also initiate the contact without you contacting us. And then also when talking about the upcoming changes, there was a question earlier today about the GRIP2. Will migration to GRIP2 have impact on Mars? Yes, it will impact the Mars, but for the data produced in those cycles, which are producing only GRIP2 data. So we will not re-archive anything. Things which are in GRIP1 in Mars will stay in GRIP1. With GRIP2, we introduce some additional level types, which will also impact Mars. So at the moment, level types, we have a surface, and surface assumes, for example, levels below ground, levels at the surface, and also levels, things like 2-meter temperature, 10-meter wind, and 100-meter wind. We treat all that as a surface, which is quite incorrect. So we will introduce these additional levels. For example, at the moment, we have a different parameter for each temperature level below the surface. So we have 4 temperature for 4 surface levels, and we call them by different parameters. But in fact, this is one parameter on different levels below the surface. So we will have soil, we will have additional levels which are height above ground and stuff like that. Also with the destination Earth data and some other products, we create sub-hourly time steps. So now when you submit step, when you give it a value in Mars request, it can be a number or range. And then when it's assumed that units are hour. So we will also add within GRIP2 additional units, which means when you are retrieving this data in Mars, you will need to provide units for the steps. So there are 2 options. For example, you could do 50 minutes, 30 minutes, but you can also specify step unit as a separate Mars keyword, and then use minutes or hours there. This is not yet in Mars. This is something that will come, and you cannot test it for now. Also for the many chemical species, for mixing ratio of many chemical species, and we have hundreds of them, we use different parameters. But in fact, with the grip2, it's possible to have one parameter, which is mass mixing ratio, for example, and then you have numerous chemical species. So that will also change. Okay, conveniently, during this training course today in the afternoon, we have a system session on one of the tape libraries. And I included here a screenshot of what you can see on our service status page. Let me paste the link in chat because it's not in my slide. Sorry for that. So it's this page. It's publicly available. If you open it, you will see Mars and ECFS in amber. And when you click on that amber color, you will have a description of what is happening. So Mars status is degraded because one of the tape libraries is under the system session. And if you request for data, which is exactly on that tape library, your request will be queued until library is made available again. And now we will go to the practical session. And one of the practicals is exactly that. You will find their example of a Mars request, which is asking for data on one of these unavailable tape library. And then you can see what is happening with your request. All other requests are involving data which is available online on cache. So they will be quite quick. And also, yeah, you are welcome now to ask any questions. If you don't have any questions, you can go to your exercises. I will also be doing them so that you can see. Yes, that's it.